Chapter 5, Section 5 is about transforming linear functions. And our parent function is going to be the first line that we start with. So the line we start with. And the most basic one would be y equals x. Might be y equals 2x plus 10. Most of the time it's going to be in slope-intercept form. A family of functions is a set of functions whose graphs have the same characteristics. Whose graphs have the same characteristics. And we might have the first line be y equals x, first one be y equals x plus 2, and y equals x minus 3. And you notice these three graphs all have the same slope, so those would be a family of functions. We are going to look at three types of linear transformations here. The first one is a translation, or a slide. The second one is a reflection, which is a flip. And the third one is a rotation. So we're going to look at a translation, reflection, and a rotation. Type 1, a translation, is also called a slide. And this transformation will move our line up or down. It's going to move it up or down. And if we started out with this equation, this is our parent function, y equals x. If we change that into x plus 4, obviously the plus 4 is what's changed, and that moves the graph up 4 units on the y-axis. And you can just say it moves it up 4 units. The second one, x minus 7 equals y. You might want to rewrite that as y equals x minus 7. And you'll notice we went from x to x subtract 7. So this function, the subtract 7, will move the graph down 7 spaces. So if you add or subtract, it's going to move your graph up or down. The second type we are going to look at is a rotation or turn. And I'm going to put a point right here and kind of a curved arrow that shows a rotation. This transformation turns a figure. Let's say turns a line or rotates a line. If we have the line y equals x, that line is right here. And if we changed that x to 1/8 x, means our slope is 1/8. So that means we would go up 1 and 8 to the right. That would be our new line. And you'll notice that line turned and it became less steep. So as the number gets smaller, it becomes less steep. Number 4 then, I'm going to rewrite this as y equals 12x. We started out with x and moved it to 12. And that line would be something like this. And you can see the rotation right there. So that line became more steep. As the number in front of the x gets bigger, as the number becomes smaller, it becomes less steep. As the number in front of the x gets bigger, it becomes more steep. And the third thing we're going to look at is a reflection. A reflection is sometimes called a flip. And this transformation flips the line across the y-axis. Flips the line across the y-axis. And if we had the line y equals x, it would look like this. And if we graph the line y equals negative x, it flips it across the y-axis. So this came from the right-hand side over to the left-hand side. So examples 6, 7, and 8 says describe which transformation occurred. We started with f of x equals x plus 3. We ended with g of x equals 4x plus 3. Our slope changed. It went from a 1x to a 4x. So this line is steeper or more steep. Number 7, f of x is 1/5 x plus 9, g of x 1/5 x minus 6. We were at plus 9, and we are now at negative 6. From 9 to negative 6, this graph was translated or moved down 15 spaces. And number 8, y equals, or f of x equals negative 4x plus 7, g of x equals 4x plus 7. We went from a negative 4x to a positive 4x. So this was flipped or reflected over your y-axis. Nine through 12, use the function given and apply the transformation stated to write a new equation of a line. We started out with h of x equals 2x minus 6. I think this means we want to translate that. If we translate that, we're going to move it up or down. So I'm going to change this to a 2x minus 4. From a minus 6 to a minus 4, we move that up 2 units. Number 10, we wanted to rotate this. We started with y equals negative 5x. So I'm going to change this to y equals 2x. Actually, let's call it a negative 2x. So from the negative 5 to the negative 2, that was rotated. Number 11, x equals 8. You want to reflect that across an axis. So this would become x equals negative 8. Just put the negative in there. And reflecting number 12, you just want to change this number to a negative. You would say, I'm going to call it g of x, and we're going to call that negative 1/7 x plus 4. We reflected it. And the application, florist charges $25 for the vase plus $4.50 for each flower. And this is the graph, 25 plus 450x. Question is, how will the graph change if the vase's cost is raised to 35? Well, that would be, let's call it g of x, still 450 for each flower. Now this becomes a 35. From 25 to 35, that went up 10 units on the graph. So you can see it went up 10 units. And if the charge per flower is lowered to $3, well, let's call this h of x. And I'm going to go back to this original one. That would be 3x plus 25. And that line would be a little flatter, a little less steep. It would be a little less expensive. So this would be a flatter line or less steep, however you want to say that. Flatter or less steep.